Hi everyone. In this session, we are going to discuss some of the important questions from the chapter Electricity. Important question and answer set 2. Let's start the discussion. First question. An electric lamp of 100 ohm, a toaster of resistance 50 ohm and a water filter of resistance 500 ohm are connected in parallel to a 220 volt source. What is the resistance of an electric iron connected to the same source that take much as current as all the three appliances, and what is the current through it? Here there are three resistors, three electrical appliances. The resistance of each appliance is given 100 ohm, 50 ohm and 500 ohm. From the question we can understand that it is a parallel connection. So first we are going to draw a parallel circuit. It is a parallel circuit. Here you can see the parallel connection. It is a parallel circuit. In this connection, in this circuit, resistances are connected in parallel. Now we are going to give the value R1, R2, R3. Here, what is the value of R1, what is the value of R2 and what is the value of R3? 100 ohm, 50 ohm and 500 ohm. So we are giving the value 100 ohm, 50 ohm and 500 ohm. What is the resistance of an electric iron connected to the same source that takes much as current as all the three appliances? We are going to change these three resistors and we are going to connect an iron box. That iron box is also taking the same current like these three resistors. It is same. What will be the resistance of that iron box? That resistance will be exactly equal to these three resistance. For that we are going to find the resistance, the total resistance of this circuit. Question is, what is the resistance of an electric iron connected to the same source that takes as much current as all the three appliances? If you are replacing these three appliances using iron box, that iron box is also going to take the same current like these three appliances. It will be equal, which means the total resistance of this circuit will be equal to resistance of that iron box. So here we need to find the total resistance. That will be the resistance of iron box. So here we are going to find the total resistance of the circuit. What is the equation for total resistance of the circuit if the resistors are in parallel connection? The equation is 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. We are going to substitute all the values. It will be 1 by 100 plus 1 by 50 plus 1 by 500. Here the LCM is 500. Here I am taking 500 as a common denominator. It will be 1 by R equal to 5 plus 10 plus 1 all divided by 500. It will be equal to 1 by R equal to 16 by 500. It is 1 by R. We need to take R by 1. So it will be R equal to 500 by 16. We are taking reciprocal on both sides. It will be R equal to 500 by 16, which is equal to 31.25 ohm. That is the total resistance of this circuit. When we are connecting an iron box to this circuit, that iron box is also taking the same current like these three resistors. So the resistance will be 31.25 because the voltage is same. Voltage is same and it is taking same current, which means the resistance of that iron box will be 31.25 ohm. Resistance is 31.25 ohm and voltage is given, it is 220 volt. We need to find the current. What is the equation for current I? According to Ohm's law, the equation for I is V by R. So we are writing I equal to V by R. We are substituting all the values. Then we will get I is equal to 220 by 31.25, which is equal to 7.04 ampere. That will be the current through the iron box. We are changing these three appliances using an iron box. So it is an iron box. Now what will be the current through this iron box? It will be same because the resistance is same and voltage is same, the current will be same. What are the advantages of connecting electrical devices in parallel with the battery instead of connecting them in series? The difference between parallel connection and series connection. In parallel connection, the resistance will be less, the total resistance is less, and the voltage, each device is going to get same voltage. The voltage splitting is not going to take place in parallel connection, and we can control different circuits separately. These are the three advantages. Total resistance of the circuit will be less. Each appliance will get same voltage. We can control the circuit separately. These are the three advantages of parallel connection. How can three resistors of resistances 2 ohm, 3 ohm and 6 ohm be connected to give a total resistance of 4 ohm and 1 ohm? There are three resistors. We need to connect these three resistors, parallel connection or series connection, that's upon you. But the resistance, the total resistance should be 4 ohm and question B, it should be 1 ohm. How we can connect these three resistors? There are two types of connection, series and parallel connection. If we are connecting it in series, what will be the total resistance? Just imagine we are connecting these three resistors in series. In series connection, the total resistance is R equal to R1 plus R2 plus R3. Then total resistance will be 2 plus 3 plus 6. That is 2 plus 3 5, 5 plus 6 11. It will be 11 ohm. So series connection is not possible because we need 4 ohm and 1 ohm. Next one is parallel connection. Let's check the parallel connection. We are connecting all the resistors in parallel, 2 ohm, 3 ohm and 6 ohm. And effective resistance, what is the equation for effective resistance here? It will be 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. It will be 1 by R is equal to 1 by 2 plus 1 by 3 plus 1 by 6. Here I am taking 6 as a common denominator. Then it will be 1 by R equal to 3 plus 2 plus 1 all divided by 6. It will be 1 by R equal to 6 by 6. 6 by 6 is 1 and R will be equal to 1 ohm. If you are taking reciprocal also, it will be 1 ohm. So we got the first answer. Question B. If we are connecting all three resistors in parallel, we will get 1 ohm resistance. Now second question. We need to make a circuit which is giving a resistance of 4 ohm. How we can make it? Parallel connection is over. Series connection is not possible. So we are going to mix series and parallel. Here we are going to connect 6 ohm resistor and 3 ohm resistor in parallel. First let's make the circuit. It is 6 ohm, 3 ohm and this one is 2 ohm. Now we are going to find the effective resistance. We are going to find the effective resistance. Equation for effective resistance of this parallel connection. 1 by R is equal to 1 by R1 plus 1 by R2 and 1 by 6 plus 1 by 3. 6 is the common denominator here, LCM. It will be 1 by R is equal to 1 plus 2 by 6. It will be 1 by R is equal to 3 by 6 and R will be equal to 6 by 3 and R equal to 2 ohm. The resistance here it is 2 ohm. Means the resistance of this parallel connection, it is 2 ohm. We are making it here. Now this 2 ohm and this 2 ohm, they are in series. So what will be the equation? R equal to R1 plus R2. 2 plus 2 is equal to 4 ohm. So effective resistance of this circuit is 4 ohm. When we are connecting the resistors parallel to each other, then we will get 1 ohm resistance. When we are connecting 2 resistors in parallel and 1 resistors in series, we will get 4 ohm resistance. What is the highest and lowest total resistance that can be secured by combination of 4 coils of resistance 4 ohm, 8 ohm, 12 ohm, 24 ohm? We need to find highest resistance and lowest resistance. Lowest resistance means parallel connection. Highest resistance means series connection. So we are going to connect these resistors in series and in parallel. When we are connecting it in series, what will be the equation for effective resistance? Yes, R equal to R1 plus R2 plus R3 plus R4. Just adding. When we are adding this one, we will get 4 plus 8 plus 12 plus 24, which is equal to 48 ohm. So in series connection, we are getting an effective resistance of 48 ohm. Then what about parallel connection? We are going to find the effective resistance if we are connecting these resistors in parallel. 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. We are substituting all the values. It will be 1 by 4 plus 1 by 8 plus 1 by 12 plus 1 by 24. Here we are taking 24 as common denominator. It will be 1 by R equal to 6 plus 3 plus 2 plus 1 all divided by 24. It will be 1 by R is equal to 12 by 24. 1 by R equal to 12 by 24. We need to find the value of R. So we need to take reciprocal. R will be equal to 24 by 12, which is equal to 2 ohm. That is the effective resistance if we are connecting these resistors in parallel. So highest resistance is 48 ohm and lowest resistance is 2 ohm. Why does a cord of an electric heater not glow while the heating element does? If you are considering an electric heater, that electric heater is having two parts. One is a heating element and one is a cord wire. Other one is a cord wire. This cord wire is not going to get high temperature. And this cord wire is not going to change into red hot and it is not going to glow. Why? That's the question. The heating element is made of a special material that is called nichrome. Nichrome is the combination of nickel and chromium. It is an alloy. This alloy is having high resistivity, high melting point. When electricity is passing through this coil, because of this high resistance, the temperature of the coil will increase and it will glow. Heating element is made of nichrome It is an alloy of nickel and chromium. It is having high resistance and high melting point. When electricity is passing through the coil, it becomes too hot and glow red. Cord is made of good conductors of electricity. The cord wire is made of good conductors of electricity, maybe copper or aluminum. The resistance is low, so it won't glow. The resistance of this conductor is low, so it is not going to glow. Compute the heat generated while transferring 96,000 coulomb of charge in 1 hour through a potential difference of 50 volt. We need to write the given values first. The Q, the charge is given 96,000 coulomb. The time is also given, T is equal to 1 hour. We need to convert that hour into second. 1 hour means 3600 second. So T will be equal to 3600 second, and potential difference is given, V is equal to 50 volt. We need to find the heat. We have the equation for heat, H equal to VIT. We know the value of V is 50 volt and T is 3600 second, but we don't know the value of I. How we can find the value of I if we know the value of Q and T? Yes, the equation is I equal to Q by T. What is the value of Q? Q is 96,000. What is the value of T? T is 3600 second. So it will be I equal to 96,000 by 3600. That is equal to 26.66 ampere. Now we can find the value of heat. Now we have the value of I. We are just substituting all the values in this equation. H will be equal to 50 into 3600 into 26.6, which is equal to 48 lakh joule. An electric iron of resistance 20 ohm takes a current of 5 ampere. Calculate the heat developed in 30 seconds. Very simple question. First we need to write the given values. Given values are R equal to 20 ohm, I equal to 5 ampere, T equal to 30 seconds. We need to find H, heat. We need to find heat. What is equation for heat if we have the value of I, R and T? Yes, equation is H equal to I square RT. Just substitution, H equal to 5 square into 20 into 30. It will be 25 into 20 into 30, which is equal to 15,000. H equal to 15,000 joule. What determines the rate at which energy is delivered by a current? Rate of energy, that is power. Rate of energy consumption by an electric appliance is electric power. An electric motor takes 5 ampere from a 220 volt line. Determine the power of motor and energy consumed in 2 hours. First we need to write the given values. Given values are I equal to 5 ampere and voltage V is equal to 220 volt. We need to find the power. After that we need to find energy. If we know the value of V and I, what is the equation for power? Power is P is equal to VI. Just multiplication, it will be 220 into 5, 1100 watt. That is a unit of power. Now we need to find the energy. We are going to find energy in watt hour, not in joule. We are going to find the energy in watt hour. How we can find the energy in watt hour? Energy is equal to power into time. Watt hour means energy in watt and time in hour. It's given in the question. The time is 2 hours. Time duration is 2 hours. So we can multiply the value. Energy in watt hour will be equal to 1100 into 2. It will be 2200 watt hour. If you like this video, please share this video, subscribe to my channel, and always you can ask your doubts using comment box. Thanks for watching.